ladies and gentlemen, we're going to take a look at the first real set of notes that may need some explanation from Lesson 2.4. Lesson 2.4 is about writing equations of lines. We're looking at writing equations for linear functions. And so we want to be able to write equations from a couple of different points of view. The first point of view we're going to take a look at is writing an equation from a graph. And so for writing an equation, when we see that, we want it to be, y equals mx plus b. We want to write, find the slope and the y-intercept. And so this is pretty much what you saw on the preview activity. When you're given a graph, you should always be able to calculate the slope. Your slope, once again, if we look at that, m is equal to your rise over your run. And remember, you can calculate that using ordered pairs, or you can simply count it. I'm going to find a good point. This y-intercept jumps out at me, and then I'm going to follow it along. Now, that doesn't look like a good point because it only crosses that horizontal line. It doesn't cross the vertical. Only crossing a vertical, still not a good point. Here's a good point. So I've got two good points there to be able to count my slope from. I always go from left to right. That's how we read books. That's how we read graphs, is from left to right. And so I go down 1, 2, 3, so that's a -3. I go over 2 to the right. That's a +2. So we have an m value of -3 over 2, and that matches what we see. It's a negative line. Our b, remember, is your y-intercept. And so that b value is +1, +2, +3. And so our equation is going to be y equals -3/2 x plus 3. So that's what you saw in the preview activity. What we want to do is we want to take a look at how do we write an equation if we don't have a graph, or if we don't have the y-intercept on the graph. And so what we have is the given information. For example, number 2. It says, write an equation for a line that passes through 1, 2, and has a slope of 2. So now I don't have the y-intercept. I have the point 1, 2. Doesn't fall on the y-axis. Remember, your y-intercept always has an x value of 0. But we do know the slope. So what can we use? Well, we can use what's called point slope form. That's what we have. We have an ordered pair, we have an xy value, and we have a slope. And so what that form is y minus y1, we're going to plug in the y value from the ordered pair, is equal to m times x minus x1. So we're going to be given 3 pieces of information, and we're going to plug those 3 pieces in. Then what we're going to do is rewrite it in slope-intercept form. So what point slope form looks like is y minus y1, that's the 2. That's the 2 here, is equal to m, which was our 2, times x minus, we need to then plug in the x value. Now what we're going to do is we're going to take that equation and rewrite it. We're going to distribute and then isolate y. So I've got y minus 2 is equal to 2 times x minus 1. Distribute. I've got 2x minus 2. And we're going to add 2. We have this plus 0, or y equals 2x. Well, in math, we like to have a way to verify our work. That's one of the reasons I love math. We can usually prove our answer is correct. And so one way of doing that is by taking a look at the calculator. So we're going to get out of this screen right here. Let's see, we'll clear the key history. So what you want to do is you want to take this equation, y equals 2x plus 0, and we want to check and see, does it go through this ordered pair? I know it has the right slope. Here's the same m value that we had. What I'm checking for is that ordered pair. So if we go to y equals, and if you remember, guys, some of you had issues with remembering calculator keystrokes from video to class. Write down these calculator keystrokes. They're right here, guys. Write those down. Y equals. Write that down on your paper if you're afraid you'll forget what to do with there. But we're going to go y equals, clear out anything that's there, and then we're going to type in 2x. If you wanted to put the 2x plus 0, that's fine. It's going to give you the same equation. And now what I want to do is I'm going to look at my table. I'm going to go to table set, and let's check for some settings. I'm starting at -2, that's fine. My delta table, we talked about this with slope. My delta table is 1, and that's what I want it to be. And I want my independent and dependent variables to be on auto. I want the calculator to automatically fill those. So we're going to go, once we have that, we're going to go to second graph. We're going to get to the table. And now what I'm looking for is this ordered pair. I'm looking for 1, 2. I found 1 in the x, and sure enough, there in the y is the 2. So because this equation has a slope of 2 and an ordered pair of 1, 2, I know I found the right equation. All right, so let's take a look at the next example. I want to write an equation that passes through -3, 5 and has a slope of 2/3. So we're going to use the same information we had on the last screen. If we take a look at what we did there, we started in point slope form. So we're going to take and do y minus, we're going to plug in the y1 value, so 5 is equal to m, that's my 2/3, times x minus, I have this -3. Well, remember, subtracting a negative is the same as adding, so I'm going to have plus 3 there. So we're using that rule where we subtract a negative as addition. Has nothing to do with slope, guys, and that's just the arithmetic rules. So we can change that to addition anytime we see it. We're going to distribute. We have 2/3 times x, 2/3 of 2/3 of 3, so 2/3 times 3 is 2. We have that equal to y minus 5. I'm now going to add 5. So it truly is distributing, and then either undoing the addition or subtraction that you have on the left-hand side of the equation. We get y is equal to 2/3 x plus 7. What we did with the last problem, the check we did, works just fine. So we're going to hit y equals, clear out whatever was there, type in 2/3 x, and then plus 7. Make sure you're getting the x in there. Hit second table. I don't have to go to second table set because I already made sure my table set was good. And now I'm looking for the ordered pair -3, 5. Well, my table is starting at -2. So I'm going to cursor up, and there is the ordered pair I want. -3, 5. So that table is a nice way to verify what we're doing is actually some good math there. All right, so let's take a look at our next example. Now we need to write an equation from the graph. Looks very similar to example 1. The problem is I don't have an exact y-intercept anymore. It's not crossing exactly somewhere. That could be 1/2. It could be 1/3. I don't know. And so what I'm going to have to do is find a couple of good points and then count the slope from there and then use one of those points. So if we look at your paper, we've got a good point right here. This one's not a good point because it's not exact. This is the point -1, 1. And then I have a good point as we follow that line down right here. And my paper is off a little bit, but this should be 2, -1. So what I have now is I can count slope. I go down 2 over 1, 2, 3. So my m value is -2/3. I need to use one of these two ordered pairs. It doesn't matter. I'm going to use the ordered pair -1, 1. So we're going to substitute into point slope form y minus, I need to put my y1 in there, which is 1, equals, I need to put my slope, -2/3, times x minus, I'm going to subtract a -1, so that becomes addition. We're going to distribute, I get -2/3 x, this is -2/3, is equal to y minus 1. I now need to add 1. Y is equal to negative 2/3 x. Ladies and gentlemen, if you are not comfortable with your fractions, take the time to use your calculator. Negative 2/3 plus 1 is a positive 1/3. All right, I'm going to step back and look at my answer and compare it to my graph. I have a negative slope. This line is going down. Negative slope. So far, so good. I have a positive y-intercept that is less than 1. Positive y-intercept less than 1. So far it looks good. I'm going to do the same thing I did before. I'm going to go to my calculator. Y equals. Clear it out. I'm going to type in the equation I wrote. The equation I wrote was a negative 2/3. Oops. Yeah. Oops, no, I thought I had it wrong. Negative 2/3 x. And then we had a plus 1/3. All right. What I'm looking for now is I'm going to go to that table, but I'm looking for these two ordered pairs that I have. Don't use the graph, ladies and gentlemen, because the graph doesn't always give us the accuracy. We could be close, but not necessarily hitting the exact same points because the grid isn't there. So let's do second table. I don't know what this graph it for us. Looks like we're really close, but I can't really tell here. So if we do second graph and get the table, I'm looking for negative 1, 1. There it is, and I found my 2, negative 1. So these 2 points are on my line. All right, let's talk about parallel and perpendicular next. We want to write the equation of the line that passes through 2, 0, so we have an ordered pair, and it's perpendicular. Remember, we've got opposite reciprocal slopes to the line y equals 2. So if we're going to talk about slopes here for perpendicular, I need 2 m values. My given m value is 2. This is the given one. All right. My new slope has to be opposite reciprocals. So my new slope, I'm going to have an m is equal to negative. Opposite means one is positive, one is negative, and reciprocal. So my new slope is negative 1/2, and I'm going to go through that point. So that's what point slope is going to use. I'm going to have y minus 0 is equal to m, so negative 1/2 times x minus, and then my x value is 2. So for these parallel and perpendicular ones, you're going to have to determine your slope and then use the point that's given to you. Distribute negative 1/2 times x is a negative 1/2 x. Negative times a negative is a positive, and 1/2 of 2 is 1. Y minus 0, that 0 doesn't affect anything, so that term is gone, so we're just left with y equals negative 1/2 x plus 1. If we take a look at our last example, second to last example, I believe we need to write an equation of the line that passes through the point 4, negative 3, and is parallel to the line y equals 1/4 x plus 5. Remember, parallel means the same value for each slope. So if we're going to identify the slope here, m is equal to 1/4. That is my given. My slope is positive 1/4. My new slope, because I need them to be the same, is m equals, and I just take that slope, 1/4. So now I have an ordered pair. I have a slope that I can use to write my point slope form. So I'm going to have y minus, I'm going to subtract that y value, that is a negative 3, so that becomes plus 3, is equal to m, which is 1/4, times x minus, and I'm going to plug in my x value of 4. We're going to distribute. I get 1/4 x, and then 1/4 times the -4 is -1, and that's equal to y plus 3. I now back to undoing any of the addition or subtraction, so I'm going to subtract 3 from each side to get rid of that plus 3. And I'm left with y equals 1/4 x minus 4. Parallel and perpendicular are a little bit more difficult for us to check, just because we may go through the point for -3. It doesn't guarantee that we're exactly parallel, or actually parallel to that. So you could graph both the lines, and we'll talk about that a little bit in class. You have an on your own, write an equation through a point with a given slope, and then write an equation from a graph. You've got 3 points there that you can identify and slope that you can calculate. Enjoy.